All right, in class, what we did was we estimated a model to test whether or not monthly stock market returns follow a random walk. All right. What I'm going to do here in this tutorial is we did the analysis in Excel. In this tutorial, I'm going to show you how to do it in SAS for those of you that want to learn SAS. So let me go ahead and pull the data in. So what I'm going to do here, if you've watched the previous SAS tutorials, you know that this first line of code is just specifying my output screen. When I say no center, that means that I'm left justifying my output, which is annoying if you don't put that. Anyway, what I'm going to do is I'm going to use the import wizard to pull in the data. So I'm going to hit File, Import Data. It's a CSV file, and I click Next. I now have to browse for the data, and of course this is going to be different for you wherever you've saved the data. In fact, if I can remember where I saved the data, that's helpful. Give me 1 second here. So there's the data set. You can see that it's a CSV file, monthly market returns. I'm going to double click that, and now the import wizard is pointing to this directory where the data is located. I click Next, and what it's going to do here is it's going to put it in a SAS library called work, and the member data set of that library work, I can name it. I can name it whatever I want. Maybe I'll name it R1 for random walk 1 or whatever. That's the name of the SAS data set once I pull this data in. When I click Finish, you can see that work.r1, that's the new SAS data set that I just pulled in, the CSV file now in SAS data set form, was successfully created. I got 60 observations. I can look at this one of two ways. I can click on under Explorer, I can go to Libraries. Under the Work library, there's my SAS data set. I can double click that and it can show me what the data set looks like. Alternatively, I can use a SAS procedure called proc print. Data equals work.r1. I just want to print the first 20 observations. I know there's 60 observations in there, but sometimes I'm working with large data sets and I don't want to print all of the data. So I just want to print the first 60 observations. When I click the Run button, you can see that there's the data that I'm looking at. I think I got 5 years of monthly market return data. Let me explain what this is. So this is the S&P 500 stock return. That should be self-explanatory, the 500 largest stocks. These two measures of market return are different. This is the value-weighted market return and the equally weighted market return. And the way that these are calculated is I've obtained these from the Wharton data service that I've talked about in class. And what this is this gives me the value weighted average of all stocks available on this data set from the Center for Research on Security Prices. It's called the CRISP data set. Those stocks are publicly traded stocks that are traded on the New York Stock Exchange, on NASDAQ, or on the American Stock Exchange. And so what happens is this market return is the average return of all those publicly traded stocks, but it's weighted based on the market capitalization. Now, the S&P 500 return is also weighted on market capitalization, but it only consists of the 500 largest stocks. This value-weighted market return consists of all publicly traded stocks. Likewise, this variable here is the equally weighted market return. This is the average return for all publicly traded stocks available on CRISP, but every stock gets an equal weight. So you can see that they're much different here. Although if you look at the monthly returns here, this is January of 2014. The value-weighted market return is fairly close to the S&P 500 market return. And likewise, that's true for February and March of 2014. So anyway, the value-weighted market return is going to give us something close to the S&P 500, but it has a broader market index. All right, so what I want to do here, remember in class in Excel, what we did is we estimated the following regression. I'm going to make a comment here in my code to show you what that regression is. I'm going to take the returns on the market, my left-hand side variable, in month T, and I'm going to estimate the following regression. I'm going to have an intercept A plus a slope coefficient B, And then I'm going to include the lagged market return 1 month. Of course, I have an error term in my regression. So I'm going to estimate this model here where I'm going to lag the market return, and to the extent that market prices follow a random walk, this slope coefficient should be statistically close to 0. That is, last month's stock returns shouldn't predict this month's stock returns. Okay. Again, the idea of a random walk is that there isn't predictability in market returns. So the first thing I need to do is I need to create this variable, this lagged market return variable. I'm going to do that in a data step. I'm going to use a SAS procedure to make sure that the data is sorted the way that I want it to be sorted. Work.art1 by date. And then I'm going to create a new SAS data set called R2. I'm going to set work.r1. What I've done here is I've created a new SAS data set called R2. I'm setting the previous SAS data set that we're working in, and then once I set this new SAS data set, I can create a whole bunch of new variables. For instance, I can create a lagged market value weighted return market variable by using the operator lag1. That's lagging this market return. It's going to create a new column, and it's just going to drop. It's going to lag each of the market returns 1 month. I'll show you what this looks like here in just a second. But I'm going to do this for each of my measures of market returns here. Lag S&P return is lag 1 S underscore P 500 return. Okay. So let's see here. So I'm going to create these 3 new lag variables within this data set, this data step where I've created a new SAS data set R2. I'm going to print 20 observations from this new SAS data set called R2. And what should happen is 3 new columns should appear when I print R2, and they should be lagged market returns. Let's make sure that happens. You can see this is the lagged value weighted market return, and you can eyeball this and see that this market return was just dropped 1 observation. Likewise, the lagged equally weighted return, this observation was dropped 1 space, and this gives me lagged market returns, which is important when I run this regression. So I'm going to run 3 regressions. This is just like what we did in Excel. I'm just using SAS here. I'm going to use the SAS procedure called procreg. This estimates a simple ordinary least squares regression. Data equals R2. I'm also going to put something in it. Well, let me just show you what happens if I allow it to plot some data here. So I'm going to say my model statement is just going to be my value weighted market return. I'm being careful here to make sure that this is case sensitive, but in actuality in SAS it doesn't have to be case sensitive. These could all be lowercase and it will still read in the data. And my independent variable, my right hand side variable, is the lag value weighted market return. I just click run, and when I run this, a couple of things are going to happen. It's going to produce an output. You can see that it plots a whole bunch of stuff. It might be interesting to look at these plots. Okay, it might be interesting to look at these plots, but they take up a lot of time when you're running some of these regressions on larger data sets. So what you can do, you can type in plots equals none, and what that will do is it will get rid of these plots, so the regression will run much faster. Okay, and you can see here are the parameter estimates. This is the intercept A. Okay, let me pull this. Let me pull this up and we can talk about it here. This is the intercept A. Remember, this is the model I'm running here. This is the intercept A, and then this parameter estimate is the slope coefficient B. Okay. Again, the idea is if market returns follow a random walk, the slope coefficient won't be correlated with last month. The slope coefficient for returns last month should not be correlated with the returns this month. And you can see that parameter estimate is negative 0.1336, but the t-statistic is very, very small. Remember in class we talked about a t-statistic being around 2 to be statistically significant. It doesn't appear that slope coefficient is significant when I use value-weighted market returns. Let me run some other regressions here using the other variables. I can do this for the equally weighted market return. Let's see here. And when I run this, again, the slope coefficient B here is 0.01836. The standard error is big. The t-statistic is very, very small, suggesting that at the monthly level, even equally weighted market returns seem to follow a random walk. There doesn't appear to be any predictability in the equally weighted market return. Let me do this again for S&P 500 returns. So I'm going to type in S_P500, and my independent variable, my right-hand side variable, is going to be the S&P 500 return. Hopefully this model statement makes sense. When I have my left-hand side variable, my dependent variable, I have my right-hand side variable, my independent variable, it's going to produce parameter estimates for A and for B, as well as some other test statistics to determine whether or not the intercept and slope coefficient are significant. Even with the S&P 500, it's negative 0.1705. That's the slope coefficient there. But the t-stat is still low in absolute value. So it doesn't appear that there's any predictability in monthly market returns. I'll go ahead and save this code on Canvas. I'll also save this tutorial that I'm using to show you how to estimate a random walk model using SAS instead of Excel.